when solving a quadratic equation, there are three possibilities for how many solutions there will be to the equation. There might be two solutions, there might be one solution, or there might be zero or no solutions. X squared equals 81 is an example of a quadratic equation with two solutions, meaning two values of x that make the equation true. One solution is x equals 9. 9 squared is 9 times 9, which equals 81. However, there's a second solution to this equation. The second value of x that makes this equation true is negative 9. Negative 9 squared is negative 9 times negative 9, and negative 9 times negative 9 is 81. Negative 9 and 9 are both solutions to this equation because they both make the equation true. X squared equals 0 is an example of a quadratic equation with only one solution, only one value of x that makes it true. The only value of x that I can plug into this equation and get a true statement is x equals 0. 0 squared equals 0. That is the only solution. X squared equals negative 81. Now that's an example of a quadratic equation with no solutions. There is no number that I can multiply by itself and get negative 81. To get a negative, I would need a positive times a negative, and that would not be a number squared. When I am thinking about why there could be two, one, or no solutions to a quadratic equation, I should think of the shape of a quadratic function, this parabola. So if I were trying to figure out what inputs give me an output of 81, there are two different outputs, two different points on the graph with that output. So both 9 and negative 9 give me an output of 81. However, if I'm looking for an output of 0, there's only one input. So when I'm looking at the vertex, one input gives me a particular output. And then if I'm thinking about a negative output, there are no points on this graph, no input values that give me negative 81. When I'm solving a quadratic equation, I am not allowed to use this method of just thinking, what values of x make this equation true? I need to solve my equation algebraically using inverse operations. As always, the way I do this is I think through what's happening to x, and then I use my inverse operations in the reverse order of operations. So here I have x and I square it, and then I multiply it by negative 2. Therefore, when I'm isolating x squared using inverse operations, the first thing I undo is the multiplication by negative 2. My first inverse operation is dividing both sides of this equation by negative 2. Dividing by negative 2 leaves me with x squared isolated on one side of the equation. X squared equals negative 18 divided by negative 2, which is positive 9. Now it says to take the square root of both sides. That's because square rooting is the inverse operation of squaring. When I take the square root of both sides of the equation, x squared, the square root of x squared just leaves me with x. So square rooting x squared, I get x. The square root of 9 is not just 3. So I need to remember that this equation has two solutions, both 3 and negative 3. When I plug 3 in, 3 squared is 9. 9 times negative 2 is negative 18. Also, when I plug in negative 3, negative 3 times negative 3 is positive 9, and positive 9 times negative 2 is negative 18. Next example, tracing through what's happening to x. I'm squaring x, I'm multiplying it by 3, and then I'm adding 1. So when I'm isolating x using inverse operations, the first thing I need to undo is that addition using subtraction. So my inverse operation is subtraction, subtracting 1 from both sides of my equation. That leaves me with 3x squared equals 75. X squared times 3, so in reverse order of operations, I divide by 3. That gives me x squared equals 25. I've now isolated x squared on one side of the equation. Now the way we're having you show your work is by showing the square root underneath each side. But you can be aware that it's really common to show this work here, right on the same line. It's a little confusing when you're starting though, because it looks like you wrote this whole step in one step, and that's not what we're doing. We wrote x squared equals 25, and then we took the square root. So we're going to have you do the square root underneath. The square root of x squared is just x. And then when I take the square root of 25, I find my two solutions, positive 5 and negative 5. Plugging in 5 squared is 25. 25 times 3 is 75. 75 plus 1 is 76. Negative 5 squared is also positive 25. 25 times 3 is 75. 75 plus 1 is 76.